The automatic transfer switch, or ATS breaker size should typically match or exceed the generator's main breaker rating. In a scenario where the ATS is rated for 100 amps while the generator has a 50 amp main breaker, it is recommended to use a 50 amp breaker to protect the ATS. The 100 amp rating of the ATS is likely intended to accommodate a higher current draw during the startup of certain appliances or motors, such as 3-ton air conditioners. When these devices start up, they require a higher current than their normal operating load. The ATS is designed to handle these momentary high current surges. For the wire size from the ATS to the generator, it is advisable to use wire rated for the generator's maximum amps. With a generator having a maximum load capacity of 50 amps, one should use 50 amp rated wire for this connection. The purpose of the ATS is to automatically switch between the utility power and generator power. The ATS is connected to both the main service panel and the generator. When the utility power fails, the ATS detects the loss of voltage and switches to the generator. It is important to ensure that the ATS is properly sized and protected to handle the generator's capacity and the potential startup loads of connected appliances. When selecting a breaker for an automatic transfer switch connected to a generator, several factors must be considered to ensure proper protection and operation of the system. Firstly, the generator's maximum continuous output is a crucial factor. The breaker protecting the ATS should be sized no larger than the generator's continuous output capacity. This prevents overloading the generator and potential damage. Secondly, consider the inrush current of connected loads. Many appliances and motors, especially those with inductive loads, draw a significantly higher current during startup than during normal operation. The breaker should be able to handle these short-duration inrush currents without tripping unnecessarily. Thirdly, the ampacity of the wiring connecting the generator, ATS, and main panel is important. The breaker size should not exceed the ampacity of the wires to prevent overheating and potential fire hazards. Consult the National Electrical Code, NEC, Table 310.16 for appropriate wire sizes based on ampacity and insulation type. Fourthly, coordination with other breakers in the system is important. The ATS breaker should be selectively coordinated with upstream and downstream breakers to ensure that only the closest breaker to fault trips, minimizing disruption to the rest of the electrical system. Fifthly, the voltage rating of the breaker must match the system voltage. Using a breaker with an inadequate voltage rating can lead to failure and safety hazards. Sixthly, the interrupting rating of the breaker should be sufficient to handle the available fault current at the installation location. This is the maximum current the breaker can safely interrupt without failing. Seventhly, consider the ambient temperature in which the breaker will be installed. Breakers are typically rated for operation at a specific temperature, and their current carrying capacity may need to be derated if the ambient temperature is higher. Eighthly, the type of loads connected to the generator should be considered. If there are sensitive electronic devices, a surge protective device, SPD, may be needed to protect them from voltage spikes and surges. Ninthly, ensure that all components used in the system, including the breaker, are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, all to ensure they meet safety standards. Tenthly, it is recommended to consult with a qualified electrician or electrical engineer to determine the appropriate breaker size and ensure that the installation complies with all applicable codes and regulations. In a typical scenario, let's say a generator has a continuous output of 50 amps at 240 volts. The wiring from the generator to the ATS is rated for 60 amps. The available fault current at the installation location is 10,000 amps. The ambient temperature is 30 degrees Celsius. Firstly, based on the generator's continuous output, a 50 amp breaker would be appropriate. Secondly, check the inrush current of the connected loads. If there are motors or appliances with high inrush currents, a breaker with a higher instantaneous trip rating may be needed, but the continuous current rating should still not exceed 50 amps. Thirdly, the wiring is rated for 60 amps, which is higher than the generator's output, so the wiring is adequately sized. Fourthly, coordinate the breaker with upstream and downstream breakers to ensure selective coordination. Fifthly, the breaker must be rated for 240 volts, which matches the system voltage. Sixthly, the interrupting rating of the breaker should be at least 10,000 amps to handle the available fault current. Seventhly, check the breaker's temperature rating. If the ambient temperature is higher than the breaker's rated temperature, the current carrying capacity may need to be directed. Eighthly, if there are sensitive electronic devices, install a surge protective device to protect them from voltage spikes. Ninthly, ensure that the breaker is listed and labeled by a recognized testing laboratory. Tenthly, consult with a qualified electrician or electrical engineer to verify the breaker size and ensure compliance with all applicable codes and regulations. Additional considerations for selecting a generator ATS breaker include the specific type of breaker. Molded case circuit breakers, MCCBs, are commonly used for this application. They are available in various trip characteristics such as thermal-magnetic or electronic trip, and offer different levels of protection. Thermal magnetic breakers use a combination of thermal and magnetic elements to trip the breaker. The thermal element responds to overloads, while the magnetic element responds to short circuits. Electronic trip breakers use electronic sensors to detect overloads and short circuits and offer more precise and adjustable trip settings. Another consideration is the number of poles required for the breaker. Single-pole breakers are used for single-phase circuits, while two-pole breakers are used for two-phase circuits, and three-pole breakers are used for three-phase circuits. The number of poles required depends on the configuration of the generator and the loads being served. The physical size and mounting configuration of the breaker should also be considered to ensure it fits properly in the ATS enclosure. Breakers are available in various sizes and mounting styles such as DIN rail mounting or bolt-on mounting. The availability and cost of the breaker are also important factors to consider. Breakers from reputable manufacturers typically offer better performance and reliability, but they may also be more expensive. It is important to balance cost and performance when selecting a breaker. Regular maintenance and testing of the generator ATS breaker are essential to ensure its continued reliability. Breakers should be visually inspected periodically for signs of damage or overheating. They should also be tested using a breaker test set to verify their trip settings and interrupting capacity. Over time, breakers can degrade due to environmental factors such as humidity and corrosion, or due to repeated tripping. It is recommended to replace breakers every 10 to 15 years, or sooner if they show signs of wear or damage. Proper documentation of the generator ATS breaker is also important. This includes the breaker's manufacturer, model number, serial number, trip settings, and installation date. This information can be helpful for troubleshooting and maintenance purposes. In addition to the breaker, other components of the ATS system should also be properly sized and protected. This includes the wiring, fuses, and surge protective devices. All components should be selected based on the generator's capacity and the potential loads being served. The installation of the generator ATS system should be performed by a qualified electrician or electrical engineer. They should be familiar with the applicable codes and regulations and have the experience to ensure that the system is installed safely and correctly. After the installation is complete, the system should be thoroughly tested to verify its proper operation. This includes testing the ATS switching function, the generator starting and stopping function, and the breaker trip settings. The test results should be documented and kept on file. Ongoing training for personnel who operate and maintain the generator ATS system is also important. This includes training on the system's operation, maintenance, and troubleshooting procedures. Personnel should be aware of the potential hazards associated with the system and how to mitigate them. In summary, selecting a generator ATS breaker involves considering several factors, including the generator's capacity, the inrush current of connected loads, the ampacity of the wiring, coordination with other breakers, the voltage rating, the interrupting rating, the ambient temperature, the type of loads, and compliance with safety standards. Regular maintenance and testing are essential to ensure the breaker's continued reliability. Proper documentation and training for personnel are also important. By following these guidelines, you can ensure that your generator ATS system is properly protected and operates safely and reliably. When dealing with electrical systems like generators and automatic transfer switches, safety is paramount. Firstly, always disconnect power before working on any electrical components. Secondly, use properly insulated tools and wear appropriate personal protective equipment, including safety glasses and gloves. Thirdly, never work on electrical systems in wet or damp conditions. Fourthly, if you are not comfortable working on electrical systems, consult a qualified electrician. Fifthly, familiarize yourself with the National Electrical Code, NEC, and any other applicable codes and regulations. Sixthly, follow the manufacturer's instructions for all equipment. Seventhly, double-check all connections before energizing the system. Eighthly, use a multimeter to verify that voltages are correct before connecting any loads. Ninthly, label all circuits and components clearly. Tenthly, keep a detailed record of all work performed on the system. 11thly, regularly inspect the system for signs of damage or wear. 12thly, replace any damaged or worn components immediately. 13thly, do not attempt to repair equipment unless you are qualified to do so. 14thly, if you suspect a problem with the system, contact a qualified electrician. 15thly, be aware of the potential hazards of electricity, including shock, arc flash, and fire. 16thly, know the location of the nearest emergency shut-off switch. 17thly, have a fire extinguisher readily available in case of an electrical fire. 18thly, if someone is being shocked, do not touch them. Disconnect the power source first. 19thly, learn cardiopulmonary resuscitation (CPR) in case of an emergency. 20thly, always err on the side of caution when working with electricity. By following these safety precautions, you can minimize the risk of accidents and injuries when working with generator ATS systems. The selection of the correct overcurrent protection device, whether a circuit breaker or a fuse, for an automatic transfer switch and its associated generator, is critical for the safety and reliability of the entire standby power system. The primary goal of the overcurrent protection is to protect the wiring and equipment from damage due to overloads or short circuits. The selection process involves several key considerations. Firstly, determine the full load current of the generator. This is the maximum continuous current that the generator can supply without exceeding its rated capacity. The generator's nameplate will typically list this value. Secondly, select an overcurrent protection device with a continuous current rating that is at least 125% of the generator's full load current. This is to account for potential overloads and to prevent nuisance tripping. For example, if the generator's full load current is 40 amps, the overcurrent protection device should have a continuous current rating of at least 50 amps, which is 40 amps times 1.25. Thirdly, consider the interrupting rating of the overcurrent protection device. This is the maximum fault current that the device can safely interrupt without failing. The interrupting rating must be greater than the available fault current at the point of installation. The available fault current can be determined by performing a fault current study. Fourthly, select an overcurrent protection device with an appropriate time current characteristic. This characteristic describes how the device will respond to different levels of overcurrent. For example, a fast-acting fuse will trip quickly on a short circuit, while a time delay fuse will allow for brief overloads, such as motor starting currents. Fifthly, coordinate the overcurrent protection devices in the system to ensure selective coordination. This means that the overcurrent protection device closest to the fault should trip first, while upstream devices should remain closed. This minimizes the impact of the fault and prevents unnecessary outages. Sixthly, consider the ambient temperature in which the overcurrent protection device will be installed. The current carrying capacity of the device may need to be derated if the ambient temperature is higher than the device's rated temperature. Seventhly, select an overcurrent protection device that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or this ensures that the device has been tested and certified to meet applicable safety standards. Eighthly, install the overcurrent protection device in a suitable enclosure that provides protection from environmental conditions such as moisture and dust. Ninthly, label the overcurrent protection device clearly to indicate its function and rating. Tenthly, periodically inspect and test the overcurrent protection device to ensure that it is functioning properly. This includes verifying the trip settings and interrupting rating. In addition to these considerations, it is also important to consult the National Electrical Code, NEC, and any other applicable codes and regulations. The NEC provides detailed requirements for the selection and installation of overcurrent protection devices. It is also recommended to consult with a qualified electrical engineer or electrician to ensure that the overcurrent protection system is properly designed and installed. They can perform the necessary calculations and studies to determine the appropriate overcurrent protection devices and ensure that the system meets all applicable codes and regulations. They can also provide guidance on the maintenance and testing of the system. The automatic transfer switch itself may also have overcurrent protection devices. These devices are typically sized to protect the ATS from overloads and short circuits. The size and type of these devices will depend on the rating of the ATS and the characteristics of the loads that it serves. It is important to coordinate these devices with the overcurrent protection devices and the generator and the utility power supply to ensure selective coordination. The transfer switch is rated at 100 amps, while the generator is rated at 50 amps continuous. Firstly, the breaker protecting the ATS from the main service panel should be sized no larger than the generator's continuous output capacity, which is 50 amps. This prevents overloading the generator. Secondly, the wiring from the generator to the ATS should be rated for at least 50 amps. The ATS is rated for 100 amps to handle the high current draw during the startup of certain appliances or motors. The ATS is designed to handle these momentary high current surges without tripping the breaker. In a scenario where the generator has a maximum load capacity of 50 amps, the wire for this connection should be rated for 50 amps. Proper overcurrent protection and wire sizing are essential for the safe and reliable operation of a generator and automatic transfer switch system. By following these guidelines and consulting with qualified professionals, you can ensure that your system is properly protected and meets all applicable codes and regulations.